Hello and welcome to lesson 1 of week 2. In this lesson, we are going to look at the selection sort algorithm. My name is Mildred. The selection sort is such that it loops through the unsorted, finds the lowest value and brings it to the front of the unsorted part. We want to create a function that is going to simulate this algorithm. So let's say the selection sort, and we're going to pass in an array here. The first thing we want to do is to get the length of the array. Okay, so the length of the array. Now the length of the array is always counting from 1 to the total number of items, which is always 1 more than the index position, and we want to loop through from the index position that starts from 0 to the end of the array. So the length is 1 more, we subtract 1, so we can use this in the range function. So we want to have an outer loop for I in range, and we'll say this is in range n. Now because we already subtracted 1 here, we don't need to do it in the range function, and we want to set the minimum index to be what the item that is pointed to. Current iteration of I is the minimum index. Okay, and so the minimum value is assumed to be where I is for now. We want to have an inner loop, so we'll say for j in range. Now this inner loop will not touch the sorted part, which is the first part of it. So we're going to start from the unsorted part, which is going to be 1 index position higher than where I is pointed to, so it will be I plus 1. Okay, so the range will start from I plus 1 and it's going to end at n, let's say n plus 1. all right, because we subtracted 1, we're just adding it, so n plus 1, or it will be I plus 1 to n, like that, if we did not subtract 1 there, so to n plus 1. Now we want to check if the item held in this inner loop is less than the item held in that minimum index that we set. Okay, if it is less, what we want to do is to set the minimum index to be equal to current index of the inner loop, which is j. Then we want to now swap now in the outer loop, so we'll come out of this whole inner loop and we want to swap here to say the item held in the current iteration of the outer loop and the item held in the minimum index should now be equal to, so we want to swap this for the item held at the current iteration where I is should now be equal to minimum index, right? So the item held at the minimum index, and the one held at the minimum index should be equal to the one held at I. So we swap this to make sure that the lowest value is now at the front of the unsorted part, or has moved to the front of the array, and then we now return the array at the end. All right, so this is the simple algorithm. There are several ways you can think about this and do this. This is just one way I'm thinking about this. Okay, so you always check, compare, swap, and repeat until it's completely sorted. So at the end of all of this, we want to assume that this is sorted. We want to try to run this to see. So let's say we want to print selection sort, and we're passing in numbers. When we save this and we run, we have this completely sorted, so we can see how it works. So we see that based on how we describe this algorithm, it is going to go through this several times, and the more the input grows, the more iteration, and the iteration that it has when the input grows is going to be exponential, not linear. So the worst case of this algorithm is going to be n squared, right, which is the same thing as the bubble sort. So between the bubble and the selection sort, we are not seeing the worst case to be different based on the input size, and so we want to say the selection sort and the bubble sort has the same worst case scenario. But you don't always work with the best case, because you want to work with the worst case, so when you have big data, you can predict what will happen and how slow your system will become when your algorithm uses something that grows exponentially. So this is where we end this lesson. In the next lesson, we are going to look at a different sorting algorithm. Thank you, and see you in the next lesson.